right, now we're going to go on to the review part on solutions. (43) talks about molarity. Let's review what molarity means. Molarity is moles over liters. Now, 43 gives us molarity, and it gives us a volume. If you take volume times molarity, you get moles. 0.0567 liters times 0.35 moles per liter is going to give me moles. I'll let you do the math. Number 44, we're going to do volume times molarity is equal to volume times molarity. You have 0.2 of a liter of 12 molar sulfuric acid. That is equal to 2 liters times X. So you would divide it by 2. And again, I'll let you do the math. 45. An aqueous solution are mixed together. What precipitate would be formed? All right. Potassium sulfide plus copper 2 chloride. Boy, that's been a long time ago that we did that. Potassium will bond with the chlorine. Copper 2 will bond with the sulfur. Okay. Chlorides are always soluble. If we look at our solubility table, which I don't have one, but sulfides are generally insoluble. So this will be our precipitate. 46, write the net ionic equation. Net ionic equation means we're going to dissociate everything. Barium nitrate plus potassium sulfate gives us barium sulfate, which will be what precipitates, plus potassium, which will not precipitate because it will stay in solution, so we've broken them into ions, we've dissociated them. Now I just need to cross out our spectator ions. Potassium is the same on both sides. Nitrate is the same on both sides. Our net ionic equation will be barium plus sulfate gives us barium sulfate. 6 strong acids. The 6 strong acids: hydrochloric acid, hydroiodic acid, hydrobromic acid, nitric acid, sulfuric acid, and perchloric acid. All of these will dissociate when you dissolve them. Weak acids do not dissociate. So if you have a weak acid, like vinegar, and you put it into water, it will not dissociate, it will just dissolve. A strong acid, like hydrochloric acid, will dissociate, which is what makes it strong. Electrolytes are things that will dissolve in water and conduct electricity. Strong electrolytes conduct electricity well. This includes strong acids and most of our soluble compounds. Weak electrolytes conduct it weakly, obviously. Those are our weak acids usually. Non-electrolytes will not conduct electricity. So anything that is covalent will be a non-electrolyte. What does dissociation mean? Dissociation means that you have a compound who is ionic, and that when you dissolve it in water, the hydrogen bonding, or not the hydrogen bonding, the water dissociates, pulls it apart, and surrounds it. So, sodium chloride added to water will dissociate into sodium ions and chloride ions. And those would be then surrounded by water molecules. Something that doesn't dissociate, but simply dissolves, would be a substance. Well, let's use our weak electrolyte. HC2H3O2 is vinegar, acetic acid. It's going to stay as a molecule, but it is going to have a positive end and a negative end. So the water molecules will still surround it, but they surround the whole molecule. And there's a very good picture in your notes of that. All right, our last question is a molarity titration question. We have a 30 mole sample of sodium hydroxide, and we're titrating it with hydrochloric acid. This is a 1-to-1 reaction. We have 0.030 liters and 0.042 liters of hydrochloric acid. The hydrochloric acid has a molarity of 1.2. What is the concentration of NaOH? First, we need to convert our hydrochloric acid to moles. Liters cancel. That will leave us with moles. All right, 0.5, 0.4 moles. It's asking for molarity. Molarity is moles divided by liters. So we take that answer divided by 0.03, and we get 1.68 for our molarity